Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. So for this week, you will learn about two-phase method, which is an alternative to the Big M method. Okay, so for the first phase, there are 4 steps. Step 1, same as step 1 in the Big M method, refer to section 3.4, and then in step 2, you need to change the objective function to minimize the sum of the artificial variables. So the new objective function should be minimize R instead of Z equals to the summation of artificial variables. So you need to ignore the original LP's objective function. Okay. In step 3, same as steps 2 and 3 in the BM method, so you can refer to section 3.4. And step 4, we need to check at the optimal tableau if the R value less than or equals to 0, only then we proceed to phase 2. Otherwise, stop as the LP problem has no feasible solution for the case where R greater than 0, then we need to stop because the problem has no feasible solution. Okay. So in phase 2, if R less than or equals to 0, step 1, we need to obtain an initial tableau for phase 2 by first deleting artificial columns in the optimal tableau from phase 1. Second, replacing the row 0 or row Z with the objective function of the original LP problem. So we take the original objective function. Okay. And then in step 2, all BBs must be eliminated from row 0 before beginning the simplex by getting a new row 0. In step 3, same as step 3 in the Big M method. So you can refer to section 3.4. Okay. So let's look at example 3.10. Refer to example 3.9. Solve the LP problem by using the two-phase method. So in the phase 1, we need to change the objective function so that regardless whether the LP problem is maximized or minimized, in the first phase, phase 1, we always want to minimize the summation of the artificial variables. So for this case, phase 1, we have only 2 artificial variables, which are A2 and A3. So we want to minimize R equals to A2 plus A3. Okay, so initial tableau will be PV. So instead of Z, now we use R in the phase 1. And then we have S1, A2 and A3 as the BV, same as example 3.9 by using BI method. Okay, so first variable x1, x2, s1, s2, a2 and a3. Okay, and then we have right hand side. So these three rows same as BI method. 1, 0, 0, 0, -1, 0. Then we have 0, 1, 0, 0, 0, 1. Right hand side 4, 20 and 10. And for row 0, we have 0, 0, 0. So R minus A2 minus A3 equals to 0, right? Okay, 0. And then we have -1, -1, and 0. So for this case, we notice that A2 and A3 are BV, but then the coefficient in row 0 are not equals to 0. That's why we need to update row 0. So update row 0 so that it becomes 0 here. So the formula is row 0 new equals to row 0. So A2 and A3 at row 2 and row 3. So row 2 and row 3. And the coefficient here -1, -1. Therefore, here +1, +1. Okay, so in the next tableau, updated initial tableau. So the new row 0 will be 2, and then 0 plus 3 plus 1, so 4, 0 plus 0 plus 0, 0, 0 plus -1 plus 0, -1, -1 plus 1 plus 0, so 0, -1 plus 0 plus 1, so 0, 0 plus 20 plus 10, so 30. Okay, now the row 0 has been updated, so we can proceed with Simplex Algorithm. Because this problem is minimize R, so we don't want any positive value at row 0. Therefore, we choose the most positive value, which is x2, the coefficient of x2, as the entering variable. So x2 entering variable, and then by using ratio test, 4 over 1 over 4 we get 16, 20 over 3 we get 6, 2 over 3, 10 over 1 we get 10. So the lowest or smallest ratio, non-negative ratio, is here. Therefore, x2 will replace a2 in the next tableau. So 3 is the pivot element. So we proceed to the next tableau, tableau 1. Alright, so in tableau 1, the new BVs S1, X2, and A3 So row 2 new, row 2 over 3. So we get 1 over 3, 1, 0, negative 1 over 3, 1 over 3, 0, and 20 over 3. Okay, so here should be zeros. Okay, for row 0 new, row 0, and row 2. So here we have positive 4, therefore here negative 4. So 2 over 3, 0, 0, 1 over 3, negative 4 over 3, 0, 10 over 3. Row 1, new, row 1. So here we have 1 over 4, positive, so negative 1 over 4. So we get 5 over 12, 0, 1, 1 over 12, negative 1 over 12, 0, 7 over 3. Row 3, row 3. So here positive 1, therefore here negative 1. 2 over 3, 0, 0, 1 over 3, negative 1 over 3, 1, 10 over 3. So this is Tableau 1. From here we can see that there are still positive coefficient in row 0. So we choose the most positive coefficient here. So we choose x1 as the entering variable for the next Tableau. And then by using ratio test, we get the ratio here 28 over 5, 20, and 5. So the smallest ratio is 5. So the pivot element is 2 over 3. And A3 will be the leaving variable for the next Tableau. So in Tableau 2, the VVs S1, X2, and X1. So row 3 new, will be 3 over 2, row 3. So here we get 1, 0, 0, 1 over 2, 1 over 2, negative 3 over 2, 5. So for row 0, new, row 0, minus 2 over 3, row 3 new. Sorry, here in Tableau 1, row 2 new. Okay, we continue. Tableau 2, so row 0 new will be 0, 0, 0, 0, -1, -1, 0. And then row 1 new, row 1, row 3 new. So here 5/12, therefore here -5/12. So we get 0, 0, 1, -1/8, 1/8, 5/8, and 1/4. For row 2, new, row 2, row 3 new, so here 1/3, so -1/3. So we get 0, 1, 0, -1/2, 1/2, -1/2, and 5. So from Tableau 2, we can see that this is the optimal Tableau for phase 1. Optimal Tableau for phase 1, because there is no more positive coefficient in row 0. Okay, so for the next phase, phase 2, we must remove these 2 columns, A2 and A3, because they are fake variables or artificial variables. So we can remove, and then we need to replace row 0 by the original objective function from the LP problem. Okay, so for initial Tableau in phase 2, the original objective function is minimize z equals to 2x1 plus 3x2. Okay, so z minus 2x1 minus 3x2 equals to 0. Okay, so for row 0, it will be z -2, -3, 0, 0, 0. So here we can see that x1 and x2 are BBs, but the coefficient in row 0 are not equals to 0. Therefore, we need to update row 0. So update row 0, and the formula is row 0 new equals to row 0. So x1 in row 3, and x2 in row 2. So here -2, so positive 2, -3, so positive 3. So we use this formula to update this Tableau. So row 0 for the updated initial Tableau will be sec 0, 0, 0, -1/2, and 25 for the right hand side. Okay, so there is no more positive coefficient for this minimization problem. Therefore, we can conclude that this is the optimal Tableau. x1 equals to 5, x2 equals to 5, s1 equals to 1 over 4, and z is 25. So as a conclusion, for two-phase method, what we need to do is we change the objective function by minimizing r, which is equals to the summation of all artificial variables. And then after getting the optimal tableau here, tableau 2 for phase 1, so if r less than or equals to 0, we proceed to phase 2 because there is a feasible solution. But if r greater than 0, then we stop at phase 1. There is no solution for this problem. Okay. So in phase 2, we remove these two columns, A2 and A3, and then we take the original objective function, which is z equals to 2x1 plus 3x2, and then solve by using Simplex Algorithm. Okay, that's it for this week. So please do exercise 3.3 as your homework and submit at GC. Thank you, and see you next week. Assalamualaikum.
Please do exercise 3.3 as your homework and submit at Google Classroom by this Friday. If you have any problem, feel free to discuss in WhatsApp group. Thank you.